Now we move on to topic 4, which is on descriptive statistics. These are quantities that basically summarize information in an entire data set. So the data set is a lot, and then we want to use just one or two quantities to give general idea of what is going on in the entire data set. Before we get to that, we'll talk about population and sample. So population refers to the entire data set, which contains all possible items of interest, whereas the sample refers to a subset from the population, and what we hope is that that subset is representative of the entire population. So this could be the entire population of the human race, like everyone in the universe. And then say we've discovered a vaccine and we want to test it out. Definitely you wouldn't be able to test it on everyone in the universe, right? So you need a sample to test whatever vaccine you have developed on. And that sample, we hope, is representative of the entire population. So generally, the sample will be much smaller than the population. So that's the difference between population and sample. The PEDI 2061 class could be a sample from the sophomore year in LSU, right? So the sophomore year in LSU is every single student in second year in LSU. But PEDI 2061 students is just 24 students. And then for whatever calculations, whatever descriptive statistics you're using on the sample to be useful, then the sample needs to be representative of the entire data set. Good. So measure of central tendency is basically the most likely value in the data set, which translates directly to the mean of the data set. And we'll talk about measure of central tendency more in the next couple slides. We also have parameters, which are measures of central tendency and other statistical characteristics that describe a population. So to describe a population, we are not limited to just the mean. We have other parameters we could use, like variance, like standard deviation, like median, and so on. So we'll be talking about different parameters we can use to describe the population. Description of the population. And we're talking about descriptive statistics. So what is statistics? It is the science of learning from data. So data by itself doesn't give conclusions. It's our job to analyze the data using some tools to learn from the data and then to reduce the complex trends and patterns in the data to succinct numerical descriptions and powerful visualization. So reducing it to succinct numerical descriptions could be reducing it to just mean and standard deviation, right? Just two values, summarizing all of the information in the data, and then some useful graphs like plots of the distribution of the data. And you'll see more on these when we get to the lab section. So once we have simple values that describe the population, and then we want to be able to visualize them. Descriptive statistics. You are working on statistics and you are describing information. So it refers to quantities such as mean, median, mode. All three are measures of central tendency. And then standard deviation, which is a measure of dispersion or variation from the mean. We have skewness and kurtosis, and we'll talk about these within the context of the moment of inertia shortly. So descriptive statistics refers to such quantities listed here which describe a given data or distribution. So again, the goal is distill all of the information in the million data sets or billion data sets to just one or two values. That gives general information on the sample or population. Typically, you wouldn't have access to the entire population. What we typically work with is samples from the population. Now we move on to talk about the expected value of a random variable. So you will see that we use capital X for random variable, and for a specific realization of the random variable big X, we refer to that as Xi. So this could be a student I, right? Whereas X is the population or sample of students. So this is usually a random variable that can have multiple items, and this is just one item in the entire population or sample. So the expected value, which is also known as mathematical expectation, can be written as follows. So this is the expected value for a random variable X. So E for expectation is the sum of Xi, right, multiplied by probability. So I'm going to create a table here real quick to explain what I'm talking about. So we could have Xi, which is like an instance in the random variable X, right? And then probability of Xi. What's the chance of Xi? Xi could be the age of students in the Petty 2061 class. So let's assume we have 19. We have 19-year-olds, we have 20-year-olds, we have 21-year-olds, 22-year-olds, 23, and let's just assume the oldest person in this class is 24. How do we get the probabilities? Well, we will need to know the number of students in this class. And that's where the concept of sample and population comes in. So here we're working with a sample, right? And most times you will be working with samples. We rarely will ever have data on the entire population. So the question is, how many students are 19-year-olds in this class? Let's assume we have 1. Let's assume we have 5. Oops. Be able to go back. Let's assume we have 5. Let's assume we have 10 of these, and then 5 again. That's 24, right? So this is 21, and then 2, and then there's 1 person who is 24. So I've assumed this is the distribution of ages in this class. So you can add it up and you get 24. So sum of n is 24. So how do we get probability? What's the probability that a student in this class is 19-year-old? It's going to be 1, right? Divided by the sum of n, which is 24. And then you put a value here in decimal points. How about probability is 20-year-old? 5 over 24, right? And then this is what, 10 over 24, and so on. So those are the probabilities. If you add up these probabilities together, what do you think it's going to be? It's 1 plus 5 plus 10 plus 5 plus 2 plus 1 divided by 24. So it's going to be 24 divided by 24. And that sum of the probability is 1. Now, how do we calculate the expected value or the mathematical expectation, which is the reason why we created this example? We need to find this product. So now you all can calculate this product, right? It's this multiplied by this. So that would be 19 over 24. I'll leave it up to you to do it on your calculator. 20 times 5 divided by 24, right? Whatever the number is. 21 times 10 divided by 24. 22 times 5 divided by 24. And so on, right? That's this product which shows up here for each item in the population. This one is 24 times 1 over 24. So this one is 1. So you add it all up, right? That's what the equation says. Sum from item I to n. This is item n. This is item 1. I equals 1 to all the way to the last item. Good. So you will add this to that, to this, to this, to this. Basically find that sum. This will be sum of xi, pxi. And that sum is your mathematical expectation. So that will be the expected age of any randomly selected student in this class. And it is a measure of central tendency. You will later see that this mathematical expectation is equivalent to the mean. So this is how you will be able to find the mean of the age of the students in this class. And I explained that here. So probability xi, or probability that a random variable is equal to xi, is the unconditional probability associated with variable x. And then later in this topic, precisely next week, we'll talk about other types of probabilities, right? This is unconditional probability. We'll later talk about conditional probabilities. Now we move on to talk about moments of inertia, and I think this is a good point to stop the video and then create another video discussing the moments of inertia.